Okay, you're given triangle ABC with these coordinates right here. You're asked to find the orthocenter of that triangle, which is the point where all three altitudes intersect, and the angle between the altitude and median both drawn from vertex A. So this line AM is the median from A, and the line AP is the altitude from A, which means this is a right angle, and this is a midpoint of BC. You're also asked to find the angle theta between the median and the altitude from A. And we won't go into all the arithmetic involved, but we will discuss the strategy. As far as the orthocenter goes, what we need is to find the equations of this dashed line CD and altitude AP, and then find the point of intersection. And this is the answer right here, 17/11, comma negative 10/11. For the equation of CD, that altitude is perpendicular to side AB. AB has a slope of negative 1/2. So the altitude has a slope that's a negative reciprocal, which is 2. And using point slope, we know the line passes through the point 1, negative 2. So y minus a negative 2 equals the slope times x minus 1. So there's the equation of altitude CD. And for AP, it's similar. AP is perpendicular to BC. BC has a slope of 3/5. So the perpendicular to that line has a slope of negative 5/3, passing through negative 2, 5, the coordinates of A. And if I get both of these equations in slope-intercept form, set them equal to each other, and solve for x, I do get 17/11. Multiply every term by 3 to clear the fractions, solve for x. Whatever you get, 17/11, plug it into one of these equations to get the y coordinate. Okay. As far as angle theta, what we need to notice is that this red triangle is a right triangle. And this segment right here is opposite angle theta. And the median is actually the hypotenuse. So if we could find the lengths of the hypotenuse and this little segment right here, or if you wanted to, the altitude, you could use right triangle trigonometry to find theta. To find the distances between these points, like from A to M, you use the distance formula. So this distance right here is the square root of the change in x squared plus the change in y squared. And if you simplify it all out, that's what you get for the length of that hypotenuse. Before you can find the length of PM, you actually have to find the coordinates of P. And so you need to find the equation of BC. Well, you already know the slope of BC. So it's y plus 2 equals 3/5 times the quantity x minus 1. Find out where the equation for AP intersects the equation for BC. Turns out it's 32/17 and minus 25/17. Now you can find this distance using the distance formula. This is what it simplifies to, simplest radical form. So the sine of this theta is PM opposite over hypotenuse, 11 radical 2 over 2. If you do put this fraction over that fraction and simplify it, you get square root of 17 over 17. So theta is the inverse sine of radical 17 over 17, about 14 degrees. There you go. Hope that helped. If you have any questions, post a comment.